And we're live. Alright, we are to lesson 4, almost there. How voltage functions in DC parallel circuits. Long story short, voltage stays the same in parallel. So whenever you go to your chart, whenever you find voltage in a parallel circuit, that's all of the voltages. Not the one I meant to hit. So Control A. And I'll get to the socrative in a second. But whenever you are doing your chart for a circuit, the R, I, E, and P. Well, you have all of your voltages, so this will be your E total, E1, E2, E3, and E4. So all your voltages, let's say you have a ton of resistors, 4 resistors. I say ton. These 4 resistors weigh 2,000 pounds. I1, I dose, I dry, I4. Okay. So let's say you were able to find 100 ohms, like you were given this, and 1.5 amps. Well, you use these numbers, 100 ohms, 1.5 amps, that's 150 volts. And then now you have all of the voltages. And that's super useful because if you have other things in the circuit, like if you had gotten any of the other pieces of data, you have gotten the largest bit of it. Just like in series circuits, where if you found current, you had the largest bit of the circuit there. Same thing with voltage in parallel. So, armed with that knowledge, let's look at the socrative. Oh, good. Everybody but Jacob, but Jacob's working on it. He's almost done. Go, 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 go. Okay. Circuit components that are connected in such a way that they provide different paths are said to be connected in parallel. Well, doesn't have anything to do with voltage. That's true. Different paths for current to go down is what makes it parallel. It either has one path or multiple paths. If it's one path, it's series. If it's multiple paths, it's parallel. When 2 voltage sources are connected in parallel in a circuit, the positive terminal the positive terminal of the first source should be connected to the negative terminal of the second source. Yeah, this one is false. This is when you're connecting batteries together. So if you were trying to jump a car off, you're going to connect the positive side to the positive side and the negative side to the negative side. That's hooking the batteries up in parallel and allowing the other battery to power the car and charge the battery a little bit. You don't want to hook them up backwards because that's going to send reverse voltages and it confuses the hell out of things. We will get in second year to some complex circuits with batteries facing in different directions and what that means and how to figure that math out. But for now, in parallel, you want them connected. I'll just show you a picture. So you want them connected. Let's make a box. Let's make a couple boxes. Making some car batteries. And let's make a terminal, and a terminal, and a terminal, and a terminal. Yay! Alright. There's my marker. Okay, let's say this is positive and negative and positive and negative. You're going to want to take your positive connection, connect both positives together, connect both negatives together, and that makes them in parallel. So if this was 12 volts and 12 volts, if you read with a meter from there to there with the voltmeter, you're going to read E total is 12 volts. Alright, parallel circuits may contain more than one voltage source. That's literally what I just showed you. Absolutely, they can contain more than one voltage source. And what that does is expands your capacity. So I've already covered this a little bit today, but this is where it should be covered. So let's say this can run for 1,000 amp hours, and this can run for 1,000 amp hours. This means it can either put out 1 amp for 1,000 hours, 2 amps for 500 hours, or 1,000 amps for 1 hour. That's what an amp hour is. If you connect two 1,000 amp hour batteries together, you get, in parallel, you get 2,000 amp hours. Pretty simple. If you had connected them in series, you would get, so in parallel, you would get 12 volts and 2,000 amp hours. In series, you would get 24 volts and 1,000 amp hours. So if you had connected these instead of this way, if you had connected it, let's use black, connected these two together and then ran like that, that would be connecting it in series. So the current has to go through one battery to the next battery, and then, so series is only allowing one path of current. Power sources connected in parallel should have the same voltage rating. Yes, you should have the same voltage rating. Things get weird when the voltage ratings aren't the same. And it's basically, it's just going to use one of the batteries until the battery levels get down to the same level. Alright. In a parallel circuit. I think I'm wearing my headphones. My headphones aren't even plugged in. Let's see. In a parallel circuit, the entire blank is dropped off across each branch. The entire applied voltage. So this is saying in a parallel circuit. Let's see if I can bring up a picture. Oh, that's not it. Pictures, DC circuits. And here's a parallel circuit. You might recognize this circuit. Oh, don't like it. Paint. Resize. Oh, that's terrible. Oh well. Yeah, the circuit is the important part. Undo. Okay, so what question am I talking about? Okay. I will clean this up a little bit. So we have, let's just take the important bits. There. So let's say we had 120 volts. The 120 volts will be applied here and here. The full 120 volts will be applied in both places. Alright, determine the voltage across resistor R2. Okay, the voltage across resistor R2. So what you're going to do first, let's do that select brush again. I like that. Let's get full screen. Okay, so like always, do your chart. We don't need the full chart, but R1, our total, R1, R2, it was 30 and what? 75. Let's grab a new color. I total, I1, I2, this was 0.5 amps. And then E total, we don't know anything. Okay, E1 and E2. So, again, going this way you multiply, so 30 times 0.5 is 15 volts. So 15 volts, we got 15 volts everywhere because it's parallel. So that's our answer, 15 volts. We can stop here. Or we could fill out the rest of it. 15 volts is the person at the top, and like 4 people put 15 volts. Good job, you 4. Okay, calculate for the total current in the circuit. Well, this one is a tiny circuit. Okay, so we have 3 batteries, each giving 10 volts. But since they're in parallel, the total voltage is 10. Your total resistance is 10. So the total current, well, 10 divided by 10 is 1 amp. We got 40. I have to think 40 is just somebody took all the numbers and added them together. Like, what? And some people multiplied. But 10 amps, or 1 amp. 1 amp is the answer because it's 10 divided by 10. Alright, I'm doing pretty good. I thought I was going to be over on like every single one of these. I'll take this time to work one of these. This is a thing I worked out where it does all the answers here. So if you're watching this, here are all the answers. So we're going to go back to the circuit. So we're going to do this bottom one. Okay. Let's see. Let's clear this out. Was there 3? I feel like there was 3. Yeah, let's just do a brand new one then. I'm going to move this up here real quick so I can see it. Alright, so we have a circuit. It is 3 resistors. We've got sorry, this is going to be a mess. I'm just trying to do it pretty quick. So we have 255 ohms, 466 ohms, and 231 ohms. I total is 4 amps. I didn't put any units on this chart. So our total we don't know. Our 1 is 255 ohms. Our 2 is 466 ohms. And our 3 is 231 ohms. That's not important. I total is 4 amps. I1, I2, I3. E total, don't know. E1, E2, E3. Okay, so we don't know most of the things. We need to combine these 3 together using the reciprocal method. I'll show you that. Open parentheses. R1 is 255 to the negative 1 plus 466 to the negative 1 power plus 231 to the negative first power. Close your parentheses and do that negative 1 one more time. Here it is typing into the calculator. 255. Oh, wait. Gotta open the parentheses. 255. Don't pay attention to the numbers that are popping up right now. Plus 466 plus 231. And then we'll close the parentheses and do the negative one one more time. So 96.2. So now we'll take that 96.2 times 4. 384.8. This will give us our voltage, 384.8 volts. 384.8 volts. Yeah. 384.8. 384.8 volts. Now we can divide each of these over. I'm just going to do that real quick. Divided by 255. So that's 1.51. 384.8 divided by 466. That's 0.83. Those are both amps. And then 384.8 divided by 231. 166 1.665, so I'll do 1.67. That gives us 1, 2, it's right at 4. I'm not going to bother adding them up. But if you add these up, it should give you like just a little bit over 4, it looks like. Or no, I think it's going to be under 4, huh? 7, 8, 9, 10, 11, 8, 13, 9, 8, 13, yeah, 19, 1, 2, 3. Yeah, 3.91. That's good enough. To find your powers, you just multiply. That's not what I meant. I times E equals P. So you would multiply out to get your powers. I will show that in the next lesson. Alright, I'm just 5 minutes over. I'm going to close this socrative out and open up a new socrative for you. Launch. 5. Alright, let's do this next socrative. I'll see you guys in just about an hour. See you guys then. And then if I did put I1 over I2, Did I end the stream? I don't think I ended the stream. Nope, we're still live. Pay no attention to the man behind the curtain.